Welcome to Study Loop.
Okay, so for this question, we know the force P is equal to 400 Newton, which means that the maximum friction is equal to static friction mu Sn, which is equal to 0.30 times 500 Newton cosine 20 degree plus P sine 20 degree. And we know P is 400 Newton, which means that it's plus 400 Newton sine 20 degree. So eventually we have the maximum friction is equal to 182 Newton. So now let's determine the friction. So the friction is equal to 500 Newton sine 20 degree minus 400 Newton cosine 20 degree. And this will give us the friction is equal to negative 205 Newton. Okay, as you can tell, the magnitude of the friction is greater than the magnitude of the maximum friction, which is the static friction, which means that the block will start sliding. Okay, and since the value for the friction is negative, that means the block will start sliding upward along the surface. Because we are considering moving downward along the surface is the positive x direction. Okay, so upward along the surface. So therefore, let's determine the actual friction, which is the kinetic friction, that's Fk, is equal to the coefficient of the kinetic friction, which is mu k, times the normal force, which is equal to 0.25 times 500 Newton cosine 20 degree plus P sine 20 degree, which is 400 Newton sine 20 degree. And this will give us the kinetic friction is about 152 Newton. And we know the kinetic friction is opposing the motion of the block. Since the block is moving upward along the surface, that means the direction of the kinetic friction should be pointing downward along the surface. If I draw an arrows, it should look something like this. So this is the direction of the kinetic friction. And there's the angle here, which is 20 degree, since it's a 20 degree inclined surface. Okay, and these are the answers for this question.